This is a continuation of the Chapter 27 video. So in the previous video we started example 187 and we looked at parts A and parts B. And we saw that this series converges to 1. Notice we started at 2 and this series converges to 1 where we started at 1. Now what I want you to notice about this part is this implies that if we take the sum starting at 2, n equal 2 to infinity of 1 divided by n squared plus 1, that this equals, well, when n is 1, we have 1 over 2. So the first term of this series is 1/2. So if the whole series converges to 1 when we start at 1, then when we start at 2, it converges to 1 minus 1/2, which is 1/2. I wanted to start this one at 2 so I could compare these two. Now part C is the sum n equal 1 to infinity of 1 over n squared. But if we notice that 1 over n squared plus n is less than or equal to 1 over n squared. That is less than or equal to 1 over n squared minus n. Remember, the larger the denominator, the smaller the fraction. And so what this tells us then is that if we look at the sum of n equal 2 to infinity of 1 over n squared, that is less than or equal to the sum n equal 2 to infinity of 1 over n squared minus n, which is 1, but it's greater than or equal to this, which is 1/2. It's greater than or equal to the sum n equal 2 to infinity of 1 over n squared plus n. So what that tells us then is if we were to start at 1 instead of 2, it's just 1 more. So we have that sum n equal 1 to infinity of 1 over n squared. When n is 1, we have our first term is 1. So this is less than or equal to 2, but greater than or equal to 3/2. We just add 1 here, and we add 1 here. So we know that this converges to something between 3/2 and 2. What is actually known, but not part of this course, is that this sum, this actually sums to pi squared over 6.